Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from CTS-131, Section 402 for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials Version 7 course curriculum, or the SRWEv7 course curriculum. And in this packet tracer tutorial and activity, we're going to be taking a look at packet tracer activity 4.3.8, where we're going to be configuring Layer 3 switching and Inter-VLAN routing. Now, let's jump over and take a look at our topology. And here it is right here. You can see we obviously have a little bit more going on than we have in previous activities. And this is really sort of the capstone activity when it comes to Inter-VLAN routing. Now, notice immediately that this is a multi-layer switch up here. Probably a 3560. In fact, if I was to issue the command show version, you can see that this is a 3560 and we're running the 12.x branch of code, 12.2 to be specific. So it is a 3560. It looks like we might have a typo here where it says Cisco Catalyst 3650, although there is a 3650 Catalyst switch. This is a 3560. But again, that first number in the switch nomenclature indicates, or used to indicate, and is a guide as to whether or not it is a layer 3 capable switch or a 2960 layer 2 capable switch. Again, that is a loose rule to follow because there are some 2960 XRs that have that routing image sort of that you can get. So here's our addressing table. You can see we're going to be doing a number of VLANs here, and we're also going to be doing a routed port, right? And what is a routed port? Well, that's a port because remember, again, a multi-layer switch, it's a router. I mean, this was a terrible marketing ploy by Cisco to talk about multi-layer switches because really they're just routers. Sure, the connectivity options are different, but at the end of the day, it's a layer 3 device. It's a router. Yeah, it's got switch ports on there and we can do VLANs, but at the end of the day, a multi-layer switch is really nothing more than a router. So we're going to configure a routed port on this device. So let's get into global config. Let's get into interface gigabit Ethernet 02. Now, if I hover over the activity here, it would have been nice to have seen. Sorry, I wanted to hover over that one. It would have been nice to have these ports labeled, but not the end of the world, right? So, I love this activity because in this activity, not only are we going to do a routed port, similar to what you would do on a router on this multi-layer switch, which is going to be our connection here to the cloud, we're also going to be doing a trunk port, just like we would do between two switches, right? So here's another great use case and something to think about for the environment that you are working in, which is, do I need a router or can I get away with a multi-layer switch, right? Because switches are typically less expensive, again, typically less expensive than routers. Again, there's all kinds of different options you could throw in there and caveats and things like that, but generally, they're cheaper. So let's dive onto that multi-layer switch. We know that Gig 02 goes out to the internet service provider, the quote-unquote cloud. Let's first say, well, the port is always up. I always say no shut out of habit to bring it up. And now let's go ahead and say no switch port, right? This is the command that turns off the layer 2 functionality of that port and turns it into a layer 3 port. In fact, before we run this, what's the command that we have to show me what the port is actually doing? Administratively, operationally, native VLAN. Let's say do show interface gigabit Ethernet 02 switch port. And look at all that information, right? Because that's all the layer 2 related information. When I say no switch port and I turn it into a layer 3 port, now when I come back and say do show interface gigabit Ethernet 02 switch port, we see that information there. And I was anticipating, and I may have to pull a layer 2 switch up here because I'm anticipating that you see something different even though Packet Tracer is showing us this. Because, again, it's not dynamic auto, and it's not static access. That is not what this port is. So while we're doing this activity, I'm going to fire up my switches here in the background in my lab to see if we can get on one real briefly to see what we would actually see on a layer 3 switch. All right, so again, that was not what I think we're going to see. I think we're going to see something different. Let's get the switches turned on here, and we'll come back to those in a few minutes. But we'll continue this activity here. So now that it's no longer a layer 2 port, it's layer 3, I can put an IP address on there, right? An IP is a layer 3 construct. So IP address 209.165.200.225, and let's make it a /30 because that is what we're being told we're going to make it. And can I now ping the 209.165.200.226, which should be that cloud that we have out there. And take a look at that. We've got connectivity out to the cloud. So fantastic. Okay. So that takes care of the routed port on that multi-layer switch. So let's keep cruising down here. So that was sort of the router-esque configuration for this multi-layer switch. Now we're going to shift gears and we're going to configure inter-VLAN routing, right? So what we just did there with that routed port, that's not really inter-VLAN routing, right? Because we're not dealing with VLANs. It's just a layer 3 interface, just like a router would have, like similar to a serial interface. So now what we're going to do is we're going to configure some VLANs and some inter-VLAN routing. So back to the multi-layer switch, which is where we're going to spend most of our time here in this activity. And let's go ahead and create these VLANs. So I'm going to say VLAN 10. The name is going to be staff, and we're going to get the VLAN names correct here this time. We're going to say VLAN 20, and the name is student. And then we're going to say VLAN 30, and the name is faculty, right? And we're going to configure and activate SVI interfaces for each of these VLANs according to the addressing table. Now they give us, and again, these interfaces are being configured because they will be serving as the default gateway layer 3 interfaces, right? So each of these switch virtual interfaces, these SVIs, these are going to be the default gateway, because if I can get the traffic up here to the multi-layer switch, the multi-layer switch can get the traffic out to the cloud. And it looks like we've even got some routing we're going to be dealing with here in a second. All right, so now this is interesting. It says configure and activate SVIs for 10, 20, 30, and 99. But you'll notice it doesn't give us 99 here. So let's go to the addressing table, and let's see if 99 shows up here. And it does, and it doesn't say that it has a name, or I don't see a name. Now, granted, it's probably going to be the native VLAN. You can see down here they configured as a native VLAN. So we're going to have to be a little tricky here. And you'll notice there's IPv6 information that needs to be configured on this multi-layer switch. So let's see what happens here. If I say interface VLAN 10, right? So we're in the interface. It says the interface has changed its state to up, and I'm going to go ahead and say IP address. We'll do the IPv4 first, 192.168.10.254. And again, this is a /24, so 255.255.255.0. IPv6 address is going to be 2001:DB8:ACAD:10:1/64. And because this is a 3560 multi-layer switch, that IPv6 functionality is there. Now, what is not here is this IPv6 address FE80::, and it's the multi-layers. We'll just say ::10 for the link local, and we'll just make all. Well, actually, we're probably not going to do that. It's a multi-layer switch. We've got 4 switches, so we'll just say : :4 link local. Again, I don't see any link local guidelines here, so we'll just make it as if it was switch number 4 because we've got 3 other switches, and we want it to be predictable, right? So we're going to throw that link local on there. Let's go ahead and then just wash, rinse, and repeat, right? So interface VLAN 20, And we're going to say IP address 192.168.20.254.0, and then IPv6 address. It should be pretty darn close. We'll put the link local on there. And then instead of having to type all this in, because I'm pretty sure that that is going to be the only difference, and it is, it's going to save us some time. What about interface VLAN 30, right? So I could probably do the same thing when and actually VLAN 20, let's make sure here, no shut. All right, so VLAN 20 didn't auto-magically come up. That's okay. So we'll say interface VLAN 30. We'll pull the IPv4 address information back, or we'll just do the IPv6 first here with 30, and we'll get our link local knocked out, and then we'll do our IPv4 address, which the third octet is simply going to be 30, and that last octet is always going to be 254 in our configuration. So now we come to VLAN 99. And so we haven't created VLAN 99 yet. So I'm going to say VLAN 99. Now, I'm going to put the name in here as native in all caps, and we may have to circle back and tweak that a little bit. Let me see if I'm seeing if we get points for this. So I'm going to leave it as all caps, right? And we'll name it native. So then we'll say interface VLAN 99. And where are we at here? We'll say IP address is going to be 255.255.0. Let's make sure we've got everything we need there. And gig02, interestingly enough, I just noticed IPv6 address FE80::4 link local. This is going to get an IPv6 address as well. I'm sure it's going to be a little bit different than IPv6 address than the others. So we'll say 2001:DB8:ACAD::A::1/64. All right, and we did get quite a few points right there. So interestingly enough, we got a lot of points there. All right, so the VLANs we believe are taken care of. Now we need to configure the trunking, right? Because this is a layer 2 switch. And again, think of this as a router, right? Now, we're not going to do all the incap.1q commands. We just need the traffic from different VLANs to be able to come across that link. So how do we do it? Well, we do the exact same commands that we would do on a layer 2 switch. We go into interface gig01. We say, well, no shut. It's already up. Again, that's sort of a habit of mine to bring the port up. We say switch port mode trunk. We're going to get a few points for that. Now, I'm going to say switch port no negotiate. We're turning off the dynamic trunking protocol, right? We're going to say switch port trunk native VLAN 99. And we're going to say switch port. Now, this is very interesting. And in a classroom setting, this provides many challenges. So I'm going to say switch port trunk incap.1q. And you're probably, and before I even run that, you're looking at that command and you might be saying, whoa, pump the brakes. Why on all the layer 2 switches do we never ever type that command in? Why do we not say switch port trunk incap.1q? In fact, if I came onto one of these switches, actually, let's make it switch 1. If I came onto switch 1 and I went into port Gigabit Ethernet 01, which I believe, yeah, it is that port. I'm just confirming it's that port, so we'll say no shut. And on this port, if I said switch port trunk incap, look, it won't even complete the command for me. I'm hitting tab, right? Command completion. Switch port trunk allowed native VLAN interface switch port trunk incap.1q. It's not going to work. The reason it doesn't work on the 2960s is because on 2960s, that is the default. And it's the only possible setting that you can have on trunk links on those 2960s for the encapsulation is .1q encapsulation, which is why we never run switch port trunk incap.1q on the layer 2 switches. Now, on the 3560, this is not true of newer Cisco switches. On the 3650, on the 3850, on the 9200s, on the 9300 Catalyst switches, you do not have to run that command on the trunk ports because, as I said, on more recent, newer Cisco switches, 3650, 3850, again, those are kind of the older ones, 9200, 9300s, Catalyst switches, you do not have to say switch port trunk in cap .1Q because that is the default. ISL is no longer a choice. So on that multi-layer switch, if I was to say switch port trunk in cap and do a question mark, you can see they only show .1Q. The thing is, on a real 3560, and this is probably a good point to time to segue here. Let me see if I can get my switches, if any of these switches are going to come up for me if I get... Oh, and you got to love it when a plan comes together, right? So here we are on a 3750. This is a layer 3 switch. So on this switch, if I was to say, let's just say show interface status here. And these ports are all disabled. So if I was to get into privilege exec and then into global config, do show IP interface. Well, actually, I see what I'm looking for there. Let's just get into interface, fast Ethernet 101. If I was here to say switch port trunk in cap and do a question mark, so there are different options you may see on older Cisco switches, and 3750s are pretty darn old. But here's that ISL, right? This used to be an option. You used to have to tell older Cisco switches what the trunking encapsulation was going to be. In fact, how would I check to see what the default trunking encapsulation is? What about do show interface fast Ethernet 101 switch port? And take a look here. The negotiation of trunking, so the dynamic trunking protocol is on. What is the administrative mode? It's dynamic auto, right? And again, this is a 3750, not as old as the 3550. I do have, I think, at least one 3550 somewhere in my setup where the default, and this guy right here, I'm not sure if this guy works or not. In fact, I removed the iOS from that guy by mistake in one of my videos, so we can't see that. I swear I have another 3550. And again, I apologize. It doesn't look like it's here. So, but on the 3550, you would see dynamic desirable there, right? So here's a 2960. And you can see that it's not configured, that there's no configuration on this. Let's go ahead and take a look here. If I was to go into global config and say, do show IP interface brief, let's just quickly get, so it's just fast Ethernet 01. So if I go into interface fast Ethernet 01 and I say switch port trunk in cap, look, real Cisco switches, 2960s that is, right? They only support .1Q. There's no option for me to configure any other trunking encapsulation, right? So again, I like to step away and look at real gear so that you can get a feeling and a better understanding, hopefully, as to why we have to run this command on the 3560, because the 3560 doesn't get it, right? It doesn't know that .1Q is the only trunking encapsulation, and that's what we're going to be using on the other side, right? And 3560's a little older, so they still have that .1Q capability, right? Or the ISL capability. So again, Packet Tracer may not score the trunking encapsulation. And the reason that it may not score it is because on the switch 1 side, it's going to be .1Q is all you can have, right? All right, so we're going to come back here. Switch port trunk encapsulation .1Q. And in a classroom setting, if you've got 3560s, you have to run this command or else it won't work. So let's take a look at interface gig 01. Do show run, because we've had a bunch of sidebar conversations here. There's all of our IPv6. Gigabit Ethernet 01. Native VLAN 99, trunk in cap .1Q, trunk, it's hard-coded as a trunk mode, or mode trunk, and DTP has been disabled, turned off. We don't need it to negotiate because we're telling it you are going to be a trunk. All right, so now we're going to come onto the switch 1 side. You knew this was going to happen because you saw the native VLAN mismatch error that we're seeing on the two switches, right? So here we are in Gigabit Ethernet 01. And we're going to say switch port mode trunk. And what if I tried to say switch port trunk in cap? No, we don't need to say that on the 2960. It already knows that. So we're going to say switch port no negotiate though, because we don't need it to be we don't need it to negotiate. We don't need DTP on. We don't want DTP on, right? And last but not least, I was waiting for that to pop up. We're still getting switch port trunk native VLAN 99. Let's match it up so that that native VLAN mismatch is going to go away. Let's say do show interface trunk. And look at that. So we've got two trunks already between switch 1 and 2 that have native VLAN 999. And this actually brings up a great question. So can a single switch have different native VLANs? And you've got your answer right here. 100% yes. The native VLAN is something that goes between the two switches. So theoretically, we could have had native VLAN 99 here. I could have had native VLAN 9 over here and native VLAN 999 over here, as long as both ends of this segment between the switches matches, we're good to go, right? Now, what's best practice? Well, best practice isn't even that. Best practice is you pick a single VLAN for your environment, and that is your environment's native VLAN, right? Because typically what I do is 999, that is typically my parking lot VLAN. And by parking lot VLAN, I mean that's the VLAN into which I put all unused ports. And we shut that VLAN down so that if for whatever reason someone tried to plug something in, you know, the port is shut down and the VLAN is shut down, right? Defense in depth is what that's called. And then I'll use 99 as my native VLAN, right? So again, typically best practice, pick one VLAN, and that is always going to be the native VLAN, and then pick another VLAN to make your parking lot VLAN. And again, parking lot VLAN is the VLAN into which we put unused ports for security reasons. So we're good to go there. And enable routing, right? So now we're going to be up here on the multi-layer switch, because watch, on this layer 2 switch, you might be thinking, oh, well, what if I just need to run IP routing, right? No, it doesn't know what that command is on a layer 2 switch because it's not capable of routing. But on this layer 3 switch, so that we have Inter-VLAN routing, if I say IP routing, we now have Inter-VLAN routing. And they also wanted me to say, let's save the config and let's say show IP route. Right? So look at that. I mean, we're running commands on this, I'm doing the air quotes here, multi-layer switch that you would want run on a router, right? And that's why, it's a router. Multi-layer switch is a router, right? Yes, we can argue about connectivity options like, well, you can't have a serial interface on it. Well, right, but I can have OSPF, I can have BGP, I can have EIGRP, I can do all those beautiful things with those dynamic routing protocols, just like I can on a router, right? So think of it like a router. So we see all these routes here, and we notice that there is no static route configured. So there's no gateway of last resort. There is no static default route here. And I'm wondering if they're going to ask us to do that down here. And they don't. Do they even give us information to the cloud? Okay, so we don't even have information to get out here to the cloud, which is why in this activity, we're not configuring any default static route, in addition to the fact, or at least I don't see it. All right, so everything looks good. So now they want us to verify end-to-end connectivity with IPv4. Or wait, we go to the cloud address, but there's a directly connected network to that cloud address. So there's nothing beyond this connection, this point-to-point connection right here. There's no web server out here. So I see what they're asking. We're going to do all of this in one fell swoop at the end. So now let's go ahead and on the multi-layer switch, let's get IPv6 unicast routing configured just like you would configure it on a router, right? And we did not do Or did I do show IPv6 interface brief? Okay, so we didn't do any. Oh, wait, I'm sorry. We did do the VLAN configuration there, which is probably why we're at 87% right now. And let me check this here real quick. So VLAN 99 has no IPv6. And then we're just going to test connectivity. So we're at 87%. And I'm curious, they're not going to be giving us points for testing the connectivity, I don't believe. So all right, let's take a quick look here. Let's make sure that everything do show run. Let's take a look at those switch virtual interfaces. Ah, take a look at that. There is an IPv6 default route statement there. All right, let's take a look here. So IPv4, there was no default route, but there is for IPv6. So VLAN 30, let's go back to the addressing table up here, and let's just make sure that everything is right. 2001 DB8 ACAD :10::1, that's correct, :20, :30. We threw some link local action in there. Everything looks good. VLAN 99 looks good. And so we should be able to test connectivity right now. Did we do on gig 02? Hold on. Gigabit Ethernet 02. Yep, DB8 ACAD :A. So that is correct. Again, I'm just checking. We kind of did the addressing table up all in one fell swoop. All right, so let's test connectivity. PC3 and VLAN 10. Okay, so we'll come back up here. I'm just checking. Did we have to put the ports for the VLANs? Here, let's take a look. All right, let's come over to switch number 2, and let's go and say show VLAN brief. And let's make sure, let's make sure that, yeah, it looks like those are correct. So let's short circuit this. Let me check results here, and let's see what it doesn't like. You've got to be kidding me. It doesn't like my VLAN names again. All right, so learning some hard lessons here. Those are the VLAN names. So did it not pick that up? Because those are the names that we use. Show VLAN brief. No, 20. And boy, we named VLAN 20. So let's try this again. Interface VLAN 10. Name. Oh, I see what happened. Name I messed that up. Oh, not interface. I'm sorry. VLAN 10. Name staff. Here we go. We'll sort this out. VLAN 20. It was probably from looking up and then looking back down. VLAN 20. VLAN 20 wasn't created? That's interesting. Okay, so that's why the interface for VLAN 20 never came up. So VLAN 20 name, and I apologize there, student, and then VLAN 30, and then the name is going to be faculty, and then VLAN 99. We can name native. Whoops, sorry. Name native. Yeah, okay, so that makes a lot more sense there. And let's go ahead and make sure there's probably one other. So the VLAN 30 name, how did I possibly screw that up twice in a row? VLAN 30 is faculty. Did we not call it faculty, or did I misspell? Of course it's a misspell. VLAN 30, VLAN 30, name faculty. There we go. All right. So we're good to go with 100%. Again, I'm not going to check connectivity because I'm confident that we've got connectivity working. In fact, let's just do it off of PC0. Let's scoot back up here, and let's check from PC0. Can I ping 192.168.10? Oops, sorry. 192.168.10.1. Can I get to my default gateway? I can. Can I ping PC2? Where are we at here? The PCs. Yeah, let's try to ping PC4, actually. Can I ping PC4, which is going to be 168.20.2? And let's see if Inter-VLAN Communication is up, or I'm sorry, that's actually, yeah, that is the IP address. And take a look at that. It works great. Last thing to check, can I get, let's go out to 209.165.200.226, which I think is that interface in the quote-unquote cloud, and everything working great. All right, well, that wraps up week number 2's packet tracer activities. Again, thanks so much for watching. Let me know if you guys have any questions, and I hope to see you in the next video.